Okay, lesson 2, using long division to divide a polynomial by a binomial. I'm going to try to go through this lesson fairly quick. This is really more of a tool that's going to be important in the later sections than it is important information on its own. Although there are there's two different definitions down here, which will take a little bit of time to get used to. Hopefully you remember your elementary school long division stuff. That'll make all this much easier. So, our goal is to be able to factor higher degree polynomials. And in order to do that, we need to know how to long divide polynomials. And that's really what we're getting to in this one. So complete the following division. If we have 15x cubed minus 10x squared plus 5x, all divided by 5x. We call the top part the dividend, the bottom is the divisor, and the quotient is, you would have to actually divide it out. What you want to do is you want to break it down individually. This one works really well because each individual part divides by 5x. So you go 15x cubed divided by 5x minus 10x squared divided by 5x plus 5x divided by 5x, which is going to equal 3x squared minus 2x plus 1. And that should be our quotient. 3x squared minus 2x plus 1. So in that case, it was actually really easy. That's not usually going to be the case. This one, it just broke down really, really convenient. So we have our titles. In the example above, the divisor divided the polynomial exactly. So there was no remainder. This will not always be the case. Consider the division of 20 by 3. Complete the following. The dividend is 20. The divisor is 3. The quotient. So what's our actual numerical answer? If we're doing 20 divided by 3, 3, 6, 9, 12, 15, 18. So we have 6. We're going to have 6 whole numbers, and we're going to have a remainder of 2 in this case, because we got to 18 and we had 2 left over. So we can write this one of 2 different ways. So here's jumping back to elementary school, middle school kind of. We could write it one of 2 ways. We can either say 20 is equal to 3 times 6. So it was 3 times 6 was our whole number part of it, but then it left 2 left over at the end there. So it was 3 times 6 plus 2 remainder kind of. And this way we actually like a little bit more now that we're in this section. This is going to be kind of our go-to way of looking at it. The other way we could say it is if you're trying to divide 20 by 3, the answer is 6, but with the remainder still to be divided. The 2 still was begging to be divided by 3. We just didn't get there. And that's our other way of looking at it. You probably use this more in grade 6, grade 5, grade 6. But we kind of like this way a little bit more now because it's a bit more mathematical. It's a kind of just a single expression. So in other words, the dividend is equal to the divisor times the quotient plus the remainder. Or the dividend divided by the divisor is equal to the quotient plus the remainder still to be divided. And one more time, third way of writing it. So if you have p of x is equal to the divisor times the quotient plus the remainder, or p of x divided by the divisor is equal to the quotient plus the remainder still to be divided by the divisor. So 2 different ways of looking at it in this section, and hopefully we're going to get comfortable with both of them. Review long division. Do we know how to actually do that? 739 divided by 35. You have to put the big number in the middle, and you put the 35, the thing that's actually dividing it, out at the front. Then you have to look, how many 35s can I do in 73? The answer is going to be 2, and that's going to be 70. 2 times 35 makes 70. So you write the 2 up here, you write the product of 2 times 35 down here, and then you draw a little line and you do your subtraction thing. So 73 minus 70 is 3 left over, 3 of the 10s, and then we bring down the 9. So we have 39 still there. Well, that should be 1 of them. That leaves 35. Subtract means I have a remainder of 4. So hopefully you remember how to do those things. You should have tried that on your own, hopefully. In which case you could write it the two different ways. So you would say 739 is equal to 35 times 21. Almost, but with 4 extra. All you have to do is add 4 onto the end. And that should get there. You can try that with your calculator. Or alternatively, you say 739 divided by 35 is equal to 21 plus 4 still to be divided by 35. So the two different ways of looking at it. That's it. If you understand both these different ways of looking at it, then we just need to practice. And we need to kind of look at what happens if we have variables in here. That's the only new thing we're going to add now. So let's try and long divide some polynomials. This case, you cannot divide, you can't do the trick we did in the first one, because you can't divide 18 by x. So we're actually going to do it with long division. X squared plus 3x plus 18, all divided by a single value of x. So this is weird. How do I actually find out how much to do it by? You focus on the first term. So what do I have to multiply x by to get to x squared? That should be an x. So x times x makes x squared. You subtract the 2 and you end up with 0. You bring down the 3x. So what do I have to multiply x by to get to 3x? Well, that's just 3. That'll leave 3x. That's 0. And you bring down the 18. What do you multiply x by to get to 18? There's nothing. You don't want to actually do anything here. There's no way to make it simpler. So this is actually going to be our remainder now. So our answer is just x plus 3. Let's write this. It says which way we want to write it. The first way, the way we said we like a bit more. So we would say that x squared plus 3x plus 18 is equal to x times x plus 3 if you added 18 onto the end. So it's just 18 short, which makes x squared plus 3x plus 18. Hey, that makes sense. I'm going to skip this one. I think this isn't too hard, and this one is just a single variable anyway, so it actually doesn't help much. Let's try to do it with a binomial now. So this adds a new wrinkle. So once again, write that thing on the inside, the big one, the dividend. Yeah. Minus x minus 18, all divided by x plus 2. Okay. So now we have a whole polynomial, and we want it to equal as close as possible to 2x squared minus x. We're going to take 2 terms at a time now. And that's really kind of confusing. You don't really know how to begin. You just focus on the first term. You let the second term just be the caboose. It just follows the other guy along. We'll deal with him in time. So we're only focusing on our first term here, the x, trying to make it look like the 2x squared. So the first thing we should multiply by is 2x. That'll make this first term 2x squared. Now what happens to our second term? It's also 2x times 2, so that's going to be 4x plus 4x. So we didn't really worry about the back term. We didn't worry about making it accurate. We just let it follow along. We do subtract, just like always. So 2x squared subtract 2x squared is 0. Negative x subtract 4x is negative 5x. And now we bring down the negative 18. Bet you never thought you'd be doing long division again, ever since grade 6. But no, it comes back all the way in grade 12. Okay, so how do I get x to look like negative 5x? I say it's times negative 5. That should give me a negative 5x, and negative 5 times 2 makes negative 10. Now I'm going to subtract those two lines from each other. Negative 5 subtract negative 5 is like adding 5. It makes 0, of course, because that's why we did it. Negative 18 subtract negative 10, so plus 10 is going to be negative 8. Negative 18 plus 10 is negative 8. Okay, and that's as far as we go. We don't have enough left to multiply anymore. So we would say that 2x squared minus x minus 18 is equal to the product of x plus 2 times 2x minus 5 with a remainder of minus 8, so we got to tack the minus 8 on there. If we could subtract 8 from that, it would be all good. So you should be starting to see how we're getting very close to factored form. If there was no remainder, we would have factored this thing successfully. So that's what we're going to be doing eventually. Not this lesson yet, though. So let's try a couple more. I think we have this one. So same type of question. We're just going to try and write it in the other form now and make sure we can do it again. So y cubed minus 6y plus 20, all divided by y minus 3. So y times what to get y cubed is y squared. That makes y cubed minus 3y squared. Okay, so now we actually have a problem. We can't really subtract y's from y squareds. So actually I made a mistake on here and I'm going to start over, and you guys should as well. You need to have all the same size terms lined up. I actually forgot this. It's been a little while since I've done this. So y minus 3 on the outside, but let's rewrite the inside. And we're going to write it as y cubed plus 0y squared. You can't skip any terms. That's actually the really important thing. You could have kind of ignored the 6y and done the 0, but it kind of looks ugly. So you can't ignore any terms because there's always the caboose. There's always going to be something kind of carried over usually. So we need to keep the y squared there even if it's just 0. Then we have the minus 6y. Then we have the plus 20. Good lesson to learn. You don't want to skip terms. You could just leave a blank there and push the negative 6y further out. I've seen that. That's actually might even be more common. But for now, I'm just going to say there's nothing there. It's either this or leave it blank, but leave a gap. Okay, so once again, it's y squared, which makes y cubed minus 3y squared. Subtract. Now we can actually do it, and it looks better. So y cubed minus y cubed is nothing. Nothing. Subtract negative 3y squared is positive 3y squared. Good. Now we bring down the negative 6y. Okay, y to get to 3y squared is plus 3y. So that'll make 3y squared. And that'll make negative 9y. Once you know how to do it, it's actually just long division, so we should be pretty comfortable with this. So subtracting, this part disappears again. Negative 6, adding 9 is positive 3y. Bring down the 20. So multiply it by 3. Plus 3, it's all different terms up here. Makes my 3y minus 9. Subtract, that's nothing, and that is 29. Positive, because you're adding 9 now. Okay, that's it. We can't go any further because you can't shrink the y term, so this is going to be our remainder. So writing it this way, if we had to take y cubed minus 6y plus 20 and divide it by y minus 3, we would end up with the entire polynomial, y squared plus 3y plus 3, and 29 still to be divided. So you add 29 waiting to be divided by y minus 3. That's our leftover part. So that's the other way to write it. Okay, if you can do that, you can do the bread and butter stuff for this unit. Let's just try a couple more now. A rule. This rule is mostly for the next section. This is kind of our looking forward rule now. So our looking forward rule, when a polynomial is divided by a polynomial, a D1 though, so this is our divisor now, there exists a unique polynomial Q and R such that you'll end up with some unique thing on top and some unique remainder. There isn't multiple ways to do it. There is always going to be a unique quotient and a unique remainder. Okay, that part's not interesting. This part's the interesting part. This first dot right here. When the remainder is 0, so when there is no remainder, no remainder. When there is no remainder, then the divisor and the quotient are both factors of the polynomial. So then what you actually did was factored it. The one thing you divided by was a factor, and the thing you had remaining is a factor. So you've actually broken it down into a purely multiplication question, is what that's saying, which makes sense. If there is a remainder, then they are not factors. Then there's a remainder, so they were not good factors. So it didn't really work right. Eventually, we're only going to be concerned with this first one. We're going to try to factor it. So this second one isn't going to be as important to us. The degree of the divisor must always be less than the polynomial. Makes sense. To divide it, you can't divide. So let's look at this one right here. I don't think you have this. But in this one right here, it's a third degree. You can't divide it by a fourth degree. That won't work. It's already going to fail. So you won't be able to get to even step 1. So you have to be dividing it by something with a smaller degree. And the remainder must also be less than the degree of the divisor. So your remainder should always be, the thing that at the very end is always going to be smaller than the thing you were dividing with. Which makes sense if we look back at this last question. So we had a first degree divisor, and our remainder was just a constant. Has to be smaller than this. If it was the same size or bigger, then we could have gone further, is what that's saying. So you'll always end up with 1 degree less or more of whatever you were dividing by, is all that that's saying. So a couple common sense rules. Now let's try, I think we have 2 last examples. This wasn't it. You guys have this one, I believe, on your sheet. It says P of x is equal to 1 plus 5x cubed minus 4x plus 6x to the 4th. And it says, A, can you write this in the proper order? So let's rearrange it. 6x to the 4th plus 5x cubed minus 4x plus 1. So that's in the proper order now. And now you want to divide it by 2x minus 1, and this is b. So that was a. B, let's actually divide it. So try this on your own first. You probably should pause the video. This is the last real kind of lengthy question. Make sure you leave your gap though. Important to leave your gap. So let's actually write out the question first so you guys don't mess that up. 6x to the 4th plus 5x cubed. Our x squared comes next. I'll just leave it as a blank. Minus 4x plus 1. You will need to do every single term, so you need to have a blank there, or a 0x squared, either way. 2x minus 1 at the front. Okay, pause and try this one on your own. Okay, showing you all the work. I'll go kind of quickly, because hopefully you could do it. So it's going to be times 3x cubed. We'll get to 6x to the 4th. And the second term is going to be minus 3x cubed. Subtract, and you end up with nothing, and you end up with 8x cubed. And you bring down your nothing. So how do I do this one now? It should be 4x squared. So that times that will make my 8x cubed. And that times that is negative 4x squared. Subtract those is nothing and is positive 4x squared. Bring down my negative 4x. So you can kind of just leave it blank, but it is good to have the space because now you can get the next term already. So this should be times 2x. Positive 2x makes 4x squared minus 2x, which leaves negative 2x when you subtract. So you're adding 2. So negative 2x plus 1. And how do we get from here to here? Well, it should be minus 1, which is negative 2x plus 1, which is a remainder of 0. Kind of ran out of space. Hopefully you guys had a bit more space on your sheet. So remainder of nothing. Did they say how they wanted to see it? Yeah, in our first form. So they would say the polynomial 6x to the 4th plus 5x cubed minus 4x plus 1 is equal to the product of 2x minus 1 times 3x squared, 3x cubed, sorry, plus 4x squared plus 2x, no space on here, minus 1 bracket. And no remainder, so this is actually fully factored. And that's the question to number C, or letter C. Is 2x minus 1 a factor of our polynomial? Yes, it is a factor, because there is no remainder. I'll just say it in more thorough words than I'm going to write. But yes, this was a factor of the entire polynomial because it can be written as the one thing times the other thing, the dividend times the quotient, without any remainder, which means it's a multiplication question only, which is what we mean by factoring. Factoring means turning it all into purely multiplication. So yes, that is a factor. Every time there's no remainder, it is indeed a factor. And that's what we like to see. Now in this question, we wouldn't be done. This isn't completely factored, but it's better now. It's closer. This guy's pretty good. This guy can be gone further, and that's what we'll do eventually. Okay, last question. This is a fun little problem-solving one, so you might want to try and pause the video. It's kind of a short video, so maybe try and pause it and see if you can figure out how to do it. Okay. So we have a lot of funny things. We have to actually find out where we started in this question. We know what we divided by, we know what the quotient was, and we know what the remainder was. So we should use that first rule that we learned, that first kind of definition, the one up here. We should use this guy. So we can say P of x is equal to 2x minus 3 times x squared plus 4 minus 2 with the remainder at the end. And that's it. All you need to do is expand, turn this into a polynomial. So 2x times x squared is 2x cubed plus 8x minus 3x squared minus 12 minus 2, and collect your like terms and rearrange it. So 2x cubed minus 3x squared plus 8x minus 14. Let me just check my work. 2x cubed minus 3x squared plus 8x minus 14. Yep, indeed. Okay, that's it for this one. So 2 25-minute lessons becomes a 50-minute lesson in total. So a bit long. Hopefully you had a chance to watch the first one for homework. But we are going to go on with a new lesson tomorrow. So try these questions. I think it's a lot of definitions and a lot of just remembering stuff. I don't think it's actually too difficult, anything we've done so far. You just got to get comfortable with these two different formulas. That's the first one, and whatever the second one looks like. That's the main thing. Okay, good luck.